In this video, we are going to discuss how to prove that a given number is irrational. So before we can do that, we would want to know the definition of what an irrational number is. So we are going to, first of all, define what a rational number is, and then from there we can get the definition of what an irrational number is. Okay, so by definition we know that a rational number is any number that can be expressed in the form a over b. Okay, so from this definition we can come up now with a definition of the irrational number. Okay, so we say an irrational number is any number that cannot, okay, that cannot be expressed in the form a over b. So here we can give examples. Okay, so here I'll write rational numbers, and then on the other side I'm going to write irrational. Okay, so rational numbers can be expressed in the form a over b. So for example, we have 1 over 2 is a rational number. We can have 4 over 7, we can have 5 over 9, we can have 7 over 9. All these here are rational numbers. And then when we come to the irrational numbers, okay, we can give an example, the root of 2. So this root of 2 here can never be expressed in the form a over b. So it's an irrational number. Other numbers include root of 3, root of 5, even root of 7. So all these numbers here are irrational. They cannot be expressed in the form of a fraction. Okay, so now how do we prove that a given number is irrational? Okay, so we are going to be proving these numbers using a method that we call as proof by contradiction. Okay, so how does this proof by contradiction work? Okay, so we are going to use proof by contradiction. Proof by contradiction. So in this method, okay, if you are new to it, it will be a little bit difficult, okay, but you get used to it. Okay, so in this proof by contradiction, okay, we assume the opposite of what we want to prove. Let's say, for example, I want to prove that the root of 2 is irrational. Okay, I want to prove that the root of 2 is irrational. In this proof, which is the proof by contradiction, I'm going to assume the opposite of what I want to prove. So I'm going to say assume, okay, or suppose that root of 2 is rational. Okay, so remember, I want to prove that this root of 2 here is irrational, but in my method, which is proof by contradiction, I'm going to assume the opposite. I'm going to assume that this root of 2 is rational. Okay, so if this root of 2 is rational, it means this root of 2 can be expressed in the form a over b, okay, where the b is not equal to 0, and then this a and b have no common factor, okay, or no common divisor that is what greater than 1, okay, or their greatest common factor is just what 1. Okay, so this is the method that we are going to be using. Okay, so once we assume that, okay, and then we go on with our proof, okay, at the end of it we are going to have the equal sign, and then we are going to have what we have on the right hand side and what we have on the left hand side. Okay, so after we go through all the steps that we need in order to prove that a certain number is irrational, you're going to have a certain expression on the left and a certain expression on your right. So the certain the expression that you always have on your left, okay, should be the one that you want to prove. So in this case, on our left we can have the root of what 2. Okay, we can have the root of 2 on our left, and then whatever manipulations that you make, okay, to this equation here, you have it on your right. Okay, so when you reach this point, you are going to conclude based on what you have on the right, and what you have on the left. So on the left you have this irrational number, okay, the root of 2, and then what you are going to have on your right there will be a rational number. So this irrational number, root of 2, can never be equal to what? An irrational number there. Okay, so immediately you get that contradiction at the end of your proof, then that would mean that you have proved by contradiction that the number that you were given, okay, in this case I'm given an example of root of 2, that it is what? Irrational. Okay, so to understand it better, let us do an example. Okay, so the first question that we are going to do, we are going to prove that the root of 2 is what? Irrational. Okay, so the question is prove that root of 2 is what? Irrational. Okay, so we are going to prove this using the contradiction method. Okay, so the first step here is to assume the opposite. Okay, so we are going to say assume, okay, assume root of 2 is rational. Okay, so if this root of 2 is rational, then it can be expressed as a fraction, right? So we are going to say if this root of 2 is rational, then there exists, okay, then there exists two integers, okay, there exists two integers, a and b, okay, such that b is not equal to 0, okay, and a and b, okay, are in their lowest terms, okay, are in their lowest terms. Okay, so what do I mean by their lowest term? It means they do not have a common factor. Okay, so if I write a over b, this a and b should not have a common factor, which should not have a number that can go into a and can also go into that b. Okay, they should not have a common factor. Okay, so this is the first statement that you are going to write in your proof, and then after that we can start our proof now. Okay, so I'm going to erase this. Okay, so after you write that statement, and then now you're allowed to write root of 2 is equals to what? A over b. Remember, this b cannot be equals to what? To 0. And this a and b, okay, are in their lowest terms, okay, meaning they do not have a common factor that can go into a and into b. Okay, and then from here, what are we going to do? Okay, we are going to square both sides. Okay, we are going to square this side, and we are also going to square this side. So why are we squaring? So that we remove this root of 2 there. Okay, so when we square this side, we are going to get 2 is equals to, okay, here this squared goes to the a and it also goes to the what? To the b. So we are going to have a squared divided by b squared. Okay, and then from here, what are we going to do? We are just going to cross multiply. Okay, we are going to cross multiply, so it means from here we are going to have a squared is equals to what? 2b squared. Okay, so that statement that I've just written, this one here, is very important because it's going to give us the first part of our proof that we need. Okay, so a squared is equals to 2b squared. What does this mean? Okay, what does this mean here? Okay, so if I have a squared which is equals to 2b squared, it means this a squared here, okay, is divisible by 2. Okay, is divisible by 2. So what does that mean? Okay, so if you have let's say I have 6, okay, and then this 6 is equals to 2 multiplied by 3. Okay, so the situation that we have here is that this 6 here will be divisible by 2. Okay, so whenever you multiply any number by 2, okay, and then the answer that you are going to get, okay, if you multiply any number by 2, so in this case this number is 3, we multiply it by 2, the answer that you are going to get is going to be divisible by 2. Okay, no wonder here we're saying a squared is divisible by what? By 2. All right, so if this a squared is divisible by 2, then it also means that its square root, okay, is divisible by what? By 2. So a is also divisible by 2. Okay, so if a squared is divisible by 2, then it means that even a will be what? Divisible by 2. So let me give an example here to make it simple. Okay, so for example, if I have 4 which is equals to 2 multiplied by 2, so I'm multiplying this 2 by a 2 and I'm getting 4. So it means this answer is also divisible by 2. And then when we take the square root of this 4, we are going to get 2. So even this 2 here will be divisible by 2. So this is the concept that we are using here. Okay, so if a squared is divisible by 2, then it means that even the a will be divisible by what? By 2. Okay, so that's what we have concluded from what we had here. Okay, if a squared is divisible by 2, it means even a will be divisible by 2. Okay, so if this a is a number that is divisible by 2, then we can write a as 2 multiplied by some number k. Okay, since this a is divisible by 2, we can write it as 2 multiplied by a certain number k. Okay, and then from our equation that we had, remember we had a squared is equals to 2b squared. Okay, so we are going to replace where there's a there, we are going to put 2k. So I'm going to write 2k and then squared is equals to 2b squared. Okay, so you distribute the power to the 2 and to the k, you're going to have 4k squared is equals to this side, you still have your 2b squared, and then divide both sides by 2. Okay, if I divide both sides by 2, I'm going to get 2k squared is equals to what? B squared. So once we reach there, we have our second part of the proof that we need. Okay, so we notice that this here is quite similar to what we had there. Okay, so in this case we had a squared equals to 2b squared, and then here we have b squared being equals to 2k squared. So what does this mean? Okay, if this one here is my answer after multiplying a certain number by 2, okay, it means this b squared here is divisible by what? By 2. So we're going to say b squared is divisible by 2. Okay, b squared is divisible by 2. So if b squared is divisible by 2, then by the same reason that we said a is also divisible by 2, we are going to say even b is what? Divisible by 2, using the same reason. Okay, so even b is divisible by 2. Okay, but remember our assumption, our initial assumption, okay, was that, let me write it here. Okay, so our initial assumption, we assumed that the root of 2 is equals to a over b. Okay, remember where b was not equal to 0, and this a and b, okay, were in their what? Lowest terms. So meaning they had no common what? Factor. Okay, but from what we are finding after proving this, okay, is that a is divisible by 2, okay, and also b is divisible by 2. Okay, so if this a and b are both divisible by 2, okay, then our initial assumption, okay, our initial assumption where we said this a and b were in their lowest terms is proved to be what? To be false. Okay, our initial assumption is proved to be false. So since our initial assumption is proved to be false, then it means that the root of 2 is irrational. Okay, because what we assumed at first is not what we are seeing in this question here. Okay, we are seeing that both a and b are divisible by 2. Okay, so we are going to say hence by contradiction, okay, hence by contradiction, root of 2 remains what? Irrational, or is irrational. Okay, so that's how we prove by the contradiction method there. Okay, so we are done with the root of 2. Let us prove that the root of 3 is irrational. So we are going to follow similar steps. Okay, we are going to follow similar steps. Okay, let us prove that the root of 3 is irrational. Okay, so the first thing is to assume the opposite of what you want to prove. So we are going to say assume, okay, we assume that root of 3 is rational. Okay, so if root of 3 is irrational, it means we can write root of 3 is equals to a over b, where b is not equals to 0, okay, and a and b are in their lowest terms. Okay, lowest terms, or they do not have a common what? Factor that can go into this a and this b. Okay, so this here will be your first statement. You are going to say assume that the root of 3 is irrational, then there exist two numbers a and b, okay, such that b is not equal to 0 and a and b are in their what? Lowest terms. Okay, and then you write root of 3 is equals to a over b. Okay, and then from there we can start our proof. So let's prove this. Okay, so we are going to say by that assumption it means the root of 3 is equals to what? A over b. And then from here we are going to square both sides. So you square this side, even the other side you do what? You square. So if I square this side, it means the root will go, I'm going to remain with 3 is equals to, here I have a squared over what? B squared. Okay, and then from there just cross multiply, it means you have a squared is equals to what? 3b squared. So remember what we did on the root of 2. Okay, since we have a number b squared, okay, being multiplied by 3 and we are getting a squared, okay, it means this a squared here is divisible by what? By 3. So we are going to say a squared is divisible by 3. Okay, so if a squared is divisible by 3, then it means even its square root, which is a, is also divisible by 3. Okay, even the a there will be divisible by 3. So if this a is divisible by 3, okay, then we can write a as a is equals to 3 by some number, what? K. Okay, and then from here we are just going to replace into this equation here. We are going to replace where we have a, we are going to put 3k. Okay, and then we do the same thing that we did when we are proving the root of what? 2. Okay, so we are going to say that a squared is equals to 3b squared, and then where there's a here we are going to put 3k. Squared is equals to 3b what? Squared. So this one here is going to give you 9k squared is equals to 3b squared, and then divide both sides by 3, divide this side by 3. Okay, what are you going to get? Okay, so when we divide that, we are going to get 3k squared is equals to what? B squared. So we see that this guy here is similar to when we had what? A squared is equals to 3b squared. Okay, so in this case, okay, we are saying we are getting this b squared after multiplying k squared by 3. Okay, so since I'm multiplying this k squared by 3 to get this b squared, it means what? It means b squared is divisible by 3. Okay, is divisible by 3. So if b squared is divisible by 3, it means its square root, which is b, is also, okay, is also divisible by what? 3. Is also divisible by 3. Okay, now remember our initial assumption that we made. Okay, we said a and b were in their lowest what? Terms. Okay, or they didn't have a common factor. We said the root of 3 was a over b, okay, where b was not equals to 0, and then the a and the b, okay, were in their lowest what? Terms. But from this proof here, after we do all these manipulations, we see that this a, okay, this a is divisible by 3, even this b is divisible by 3. So that's a contradiction that we are looking for. Okay, so because of that, okay, we are going to say hence, okay, okay, before we say that, we are going to say since, okay, we're going to say since a and b are both, okay, since a and b are both divisible by 3, okay, then you are going to say then by contradiction, okay, then by contradiction, root of 3 is what? Irrational. Okay, because we are going to have an irrational number here, okay, and then on the other side it will be a rational number. So that's a contradiction. Okay, so because of what we've stated here, okay, this root of 3 becomes what? Irrational. Okay, so that's how we can prove that a given number is irrational. Okay, so please share, like, and subscribe to my channel for more videos. Okay, you can also share this video with your friends if it has been helpful to you. So that's it for this video. See you in the other one.